Hi, welcome back. I want to, in this video, talk more about CoreFX, to talk how it works under the hood. I think you'll find this empowering to you as a developer. Really, everything that I'll talk about rests on NuGet. Not the NuGet version 2 that you're used to if you've been using Visual Studio 2013 or if you've been doing WPF or WinForms development. There's a new version of NuGet. It's called NuGet version 3. Characteristic of NuGet version 2 were a few things. When you added a NuGet reference, for instance, here I added a reference to newtonsoft.json, it wrote that into your CSproj or VBproj file, and it showed up here inside the References node in Visual Studio in Solution Explorer. It also wrote a record of what packages it had installed into this file packages.config. And also it popped up this splash screen. Actually, it didn't just pop up a splash screen. What this particular package did was, and what NuGet version 2 used to be able to do, was it had the ability to run arbitrary PowerShell scripts, install.ps1 it was called, that could do whatever they wanted. In this particular case, it didn't just pop up the splash screen like I said, it reflected upon the currently running instance of Visual Studio in order to pop up that splash screen. Now, a lot of authors have used this power to good effect, but it was altogether too much power and it's had to be removed in the interests of dependable, reliable build servers, other things. So there is no more ability to use install.ps1. Also, NuGet used to write things into your CSproj. It used to wreak havoc into your CSproj, basically. This stuff that it wrote made it really hard for people to manage their CSproj in source control, and it made it hard for them to share a CSproj between two different solutions in different directories on disk. Packages.config used to be a record of the havoc that NuGet had wreaked in your CSproj. All of this has been cleaned up and gone away. So I'm going to, in my UWP app, I'm going to manage NuGet references, and I'm going to add a reference to newtonsoft.json. By the way, the user interface for NuGet has been much improved. And what that has done is it's added a reference to newtonsoft.json NuGet package under the References node, but you'll notice some cosmetic difference. It now has a different icon. That icon is your sign that something interesting is going on under the hood. I haven't shown it in this case, but in the old world, if you added a NuGet package that depended on 10 other packages, then all those 10 other packages would also be listed in your References node, and it was easy to lose track. But in the new world of UWP apps and NuGet 3, it only shows in your References node the NuGet packages that you have chosen to install. That will help you keep track of what you've done. Also, I want to show you something interesting. Look at this screen. There's another NuGet package here that was installed by default. This one, Microsoft.NET Core.Universal Windows Platform. All of .NET Core is delivered into your app as a NuGet package. And look, under the hood here, I'm going to go into my user profile directory, I'll look in the NuGet directory, I'll scroll through, and I'll look for that one, Microsoft.NET Core.Universal Windows Platform. If I open up the NuSpec file, it depends on another NuGet package, .NET Core Runtime and .NET Core libraries themselves. And if I look inside .NET Core, I can scroll through. There are 100 or so of them, 100 or so NuGet packages that make up CoreFX. Like here, I highlighted system.link.expressions. It's part of the .NET framework, it's part of CoreFX, but it's also delivered merely as a NuGet package. By the way, this gives you a hint about why we've moved to NuGet 3. Like I said, the old NuGet 2 would show every single one of these 100 or so packages in your Solution Explorer, in your References node. That was unacceptable. That's why we've moved to a new system which only shows the one that you yourself have installed. Look at this file, project.json. That's what NuGet 3 uses instead of packages.config. It has these dependencies that are just a list of NuGet packages, And if I show hidden files, it shows this additional file, project.lock.json. This hidden file, what it's doing is when you hit build, it resolves your project.json file to discover all the packages that you yourself referenced. It figures out all of the ones that they in turn depend on. It makes sure that they're all downloaded. It figures out where they're downloaded, and it figures out which exact binaries from inside them should be referenced. It caches all of that information inside project.lock.json. Now, you yourself as a developer, you're not going to check this file into source control. It's merely there as an intermediate file. And this intermediate file is actually used by, like, the Visual Basic or C# IDE, the IntelliSense, so they know which DLLs to actually use. I want to show you a bit more. I'm going to right-click, References, Manage NuGet Packages, and I'm going to try and add a reference to SharpDX, one of the most popular libraries out there, used for graphics. But when I add a reference, this one said, package restore failed. Instead, I'm going to include pre-release ones, and I'm going to add a reference to the version 3.0 beta version of SharpDX, and that one succeeded. What's going on under the hood here? What's going on is that SharpDX, the previous stable version, 2.6.3, was doing some of that install.ps1 PowerShell magic scripting that cannot be supported any longer. What we've done with all of the popular packages, we tested them to make sure they work in UWP. When we found a package that didn't work, we reached out to the package author. We ourselves did research to discover what was wrong. We reached out to the package author to work with them to release a new version of their package that does work with UWP. In this case, the author had released a new version, this beta, that did work with UWP because it didn't do any of that magic. So we were in a good state. I want to show you one final thing. There's a piece of code here I've written using expression trees. I'm not expecting you to understand it. I don't understand it. But when I run it, it threw that exception, missing method exception. I don't know if you've ever run into it. It's pretty inscrutable. We reached out to the team involved and they said, oh gosh, that was a known bug in the RTM version that we've fixed up in a later version of the system.link.expressions NuGet package. So I went to the NuGet package manager. I looked for system.link.expressions. I picked up the latest pre-release version of it, which included the bug fix. And now when I run my app, it works perfectly. That really is showing you the power of what I talked about earlier in this video series, that everything is app local deployment. Here, I added a new reference to part of the .NET framework as a NuGet package, and it was packaged app locally into my application that I then deployed, either in debug mode for testing or to customers. That's such a marked change, right? In the past, if we wanted to do this, the only way we could do it is wait until our customers had updated their system-wide version of the .NET framework to the latest version. Or we could tell our customers to install the latest hotfix. None of those were acceptable solutions. What we've done with UWP and .NET is make the deployment story much better, much more modern. How does it all work under the hood? This is a more in-depth version of a diagram I showed you earlier. I've written my source code. I referenced a bunch of third-party libraries, maybe from NuGet. I referenced CoreFX NuGets. And I referenced the Universal Windows Platform WinMDs itself that define what APIs are present in UWP. When the VB or C# compiler do their magic, they take in their source code and they spit out the exe, but this exe is not what's deployed. If I'm in debug mode and I hit F5, it copies that exe into a subdirectory called entry point. It sticks in a native loader shim called at1.exe, whose job is to load up the .NET Core runtime called Core CLR, what's happened here, we can see that inside my AppX package, which is installed onto the device I'm testing on, it also included all of those CoreFX DLLs from NuGet. It included the UWP WinMD file that it transformed in certain ways. And this was all of the self-contained stuff that executed. If I switched to release mode, it did something quite magical instead. It took every piece of managed code from my source code, from the third-party DLLs I referenced, and from CoreFX libraries themselves. It assembled them all together into a single globally optimized native binary called app1.dll that contains every single piece of managed code turned into optimized native. Again, it has a small native loader shim whose job is to load that, and it depends on some machine-wide AppX frameworks that are the exact right version that you tested on your development machine that your AppX manifest said it depended upon. Those same versions are the ones that are used on customer machines. Daniel was talking about AppX upload to the store. When you create your AppX upload, it's not doing either of those things. It's not doing the same thing that we saw in debug nor in release. It's still taking app1.exe, it's still taking all of those third-party DLLs that you referenced from NuGet, and it's still packaging all of the CoreFX DLLs that it got from NuGet, sending all of those in the AppX upload to the store. That way, the store can know exactly what versions of which libraries you're using. But after you've submitted it to the store does this further .NET Native compilation step like you've been doing in release mode on your development machine to turn it into that .NET Native output. People ask me, gosh, all of the CoreFX DLLs from NuGet, there must be a lot of those. Doesn't that take up a lot of space? Yeah, it does. Here's an example. I wrote a small app. It's just using Win2D hardware-accelerated graphics, a small app which does fast Mandelbrot set visualizations. In my app, 1.3 megabytes of it came from the source code I wrote and came from the third-party libraries like Win2D that I referenced. The rest of my app, 4 megabytes, was taken up by CoreFX DLLs after they'd been squashed into the globally optimized thing and unused parts of it stripped out. A customer came to us with a bigger app. His app was 7.9 megabytes from his code and the third-party things he referenced, and then 2.2 megabytes was how much of CoreFX was left behind after the global optimizer had stripped out the stuff he wasn't using. Can't we do anything about that? Yes, we can. What happens is that .NET Native examines the precise set of CoreFX DLLs you're referencing, and if it sees that you're not doing anything fancy like I did with system.link.expressions beta, if you're only using the bog standard ones you get out of file new, then it removes all of those and instead it says, hey, use a system-wide version of those CoreFX DLLs that's shared between all apps on the customer device that are using this exact set of CoreFX DLLs. What that will end up meaning in practice is 2 to 3 megabytes smaller app size on the customer machine. And because it's not doing global optimization on all of CoreFX DLLs, you get faster build times as well, 30 to 40% faster build times. Now these optimizations happen automatically and transparently. The only thing that can prevent them happening is, one, if you use a beta version of a CoreFX DLL, or you can have a tweak inside your CS proj if you want to opt out of it for whatever reason. How does that work under the step? Let's look back at this diagram. What it does is in the cloud or on build when you're doing it locally, if it sees you're using all the same versions of CoreFX DLLs, then it changes your AppX manifest to depend upon this shared framework set of DLLs. Well, I've told you advanced stuff about CoreFX. The most important thing that I told you was you already knew that CoreFX and all of .NET Core is packaged locally, but in this video you've seen how exactly it's packaged locally. You've seen how it's done with NuGet, and you've seen how NuGet version 3 has some trade-offs, but they were essential to support .NET Core deployment via NuGet. So the guidance you have, like with SharpDX, the old version 2.6.3, you saw that some NuGet packages don't work in this new project.json style. If you find one, you'll have to look for help, either by reaching out to us or by reaching out to the package author, asking them if they've got anything. Also, please make sure to use the latest Visual Studio update. I'm not talking about betas, I'm talking about major Visual Studio 2015 Update 1, for instance. That will, the latest update will include the latest versions of CoreFX. It will include the latest version of the .NET runtime. It's not worth spending your time tracking down bugs if they've already been solved in CoreFX. And with that, I think this is exciting. I think the .NET Core platform is exciting. You get modern libraries. You get a modern optimizing fast startup time with .NET Native. You get brilliant debugger experience. And all of this is packaged app locally to avoid deployment headaches. I hope you have fun with it. Thank you.